What anyone really wants from a test of any kind is that it passes or fails for the right reasons. We'd like our tests to always pass when everything is working as it should, and maybe even more importantly, we want our tests to fail when something's wrong. For the same version of the software and the same version of the test, we'd like the same result every time. But lots of teams struggle to achieve this. Tests are often flaky and intermittent, giving us unpredictable results. This means that we can't really depend on them. Actually though, there are only 5 reasons for a test to fail, and if we want to, we can fix them all. So how do we eliminate intermittency from our tests, and how do we get only the failures that we'd really want? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. I'd like to begin by thanking our sponsors, Equal Experts, Octopus, Tricentis and Transfig. They all support our channel, so please do support them in turn by checking out their links in the description below. The ideas in this episode are based on one of the lessons from my new training course, Acceptance Test-Driven Development and Behaviour-Driven Development from Stories to Executable Best Specifications. It teaches a BDD-based world-class approach to the specification and testing of our systems and explores everything from how best to find and capture requirements to how to write stories that are correct even as your system changes over time. And yes, how to eliminate intermittency from your tests. Check the link in the description below to look into that course in more detail. Intermittent tests are a pain and can be a real drag on development. So much so that they can even convince teams to rely on slow, inefficient manual testing instead, because it's just too hard to get a stable automated test. This is a big mistake in my opinion, but understandable if your investment in automated tests isn't really paying off. The good news is that we can fix this. The bad news is that the reason that teams find this hard to fix is that some of the ways that we will use aren't really obvious and may seem unrelated. Let's start by ruling out some of the dumb ideas. I've already said that reverting to manual regression testing is always a mistake in my opinion. Manual exploratory testing can be great, but I don't think that manual testing is ever a sensible choice for regression testing. This is simply not something that people are good at least compared to machines. For effective regression testing, what we want is to be able to put the system that we're testing into some specific state, interact with it in some interesting ways, and then measure the results. For regression testing, ideally, we want that to be perfectly repeatable. We want the same result every time we run a test for a particular version of our system under test. Humans are just not very good at being that precisely repeatable. Machines are wonderful at it. It's their sweet spot. So let's use the machines for that part. Now, if we've automated all of that, then now we can run these things as often as we like. No more lengthy test phase weeks after development. Run these tests all the time, every day, and automate the delivery of the results to the development teams. Now you've just significantly improved the quality of your feedback and, as a result, the quality of your work. The next dumb idea is running tests that fail again. I just described our ideal test as one that gives us repeatable results. If a test doesn't do this, then what's really the point of the test? I must confess that I am confused by many of the product vendors here. Most of the build management systems that I've ever seen have some option somewhere that if a test fails, we can flick a switch and the build management system will automatically run it again. Why? What on earth is the point of that? So now we know that our test is lying to us, but we don't know if it's lying to us when it passes or when it fails. However many more times we choose to run it, it was still lying to us at least once. So now, if you choose to release it because it's okay, it's passing now, you're really taking a risk. You're releasing code that may as well not have been tested at all. You don't know any more now than you did before you ran the test the first time. Maybe there's a bug, maybe not. So the determinism of our testing matters a lot, and the way that we treat results matters a lot too. I recommend treating tests in general as a falsification mechanism rather than an attempt at proof. If all your tests pass, it doesn't mean that your system is good. Maybe your tests are wrong. Maybe you missed testing something that was important. You can never be sure, so this is no form of proof. On the other hand, as soon as you see a single test failure, you've definitive proof that your system isn't good enough, as long as your tests are deterministic. So the safest course is to reject change and go and fix the cause of the failure. When we start to think about testing in these terms as defining the releasability of our system, tests that lie to us are an even bigger pain. Actually, they're the same level of pain in reality, it's just that now we care more about the right things and are moving beyond a subjective definition of releasability. Our code is releasable when all our tests pass, and if you can't say that, improve your testing. So what things can affect the stability of our tests? What aspects of our system under test and our tests themselves can cause our tests to give us unreliable intermittent results? And what can we do to fix those things? Actually, there are surprisingly few, and we can fix them all. Except for one, and that one's the whole point anyway. There are only 5 things that cause your tests to fail. The first is the environment in which we evaluate our system. If the environment is unstable in any way, if its configuration is changing outside the scope of the system under test and its tests, then the results are now unpredictable. If your tests are happily running and passing, and I come along and reduce the available disk space by 90%, or change the version of the operating system, or perhaps reconfigure the database so that it's now in a different location, what's the impact on your test? Is your system still releasable? Because the last time we ran it, before the changes to the environment happened, everything was fine. Still fine now? We've no idea really, probably not fine, but if this change to the test environment was meant to model changes in production, then our system is probably not releasable anymore. If it was a random change in the test environment, then production might be okay, but now we've probably lost our ability to test. The environment in which our code operates is a dependency of our code. That's true whether you're responsible for it or not. If I upgrade my computer's operating system or even change to a different one, does your code still work? Again, probably not. So we must exert what control we can. The most reliable way to test our code for releasability is to exert as much control as we're able to in the context of our system over its host environment, and to test in accurate simulations of that host environment. If you're doing some form of software as a service, this should probably mean applying infrastructure as code. Version control the definition of your host environments and test in an accurate clone of production. If you write software that runs in environments that you don't control, then be clear about what environments you do support and test your software in enough samples of the range of target environments to give you some confidence. One last thought. Where you do control the host environment, the easiest, most definitive way to do this is to keep the configuration for the environment alongside the code for the system under test in version control. Now, you're certain that this version of the code works in this version of the environment. And if you're sensible, you'll trigger the build off any change to the repository, whether you're changing the environment configuration or a change to your code. Just run your deployment pipeline every time. And if moving the database is actually a problem, you'll find it out when you run the tests now. Next in my list is test data. If we want our tests to be repeatable, we need them to be isolated. If my test tries to buy a book for £5, but a preceding test changed the price of the book to £10, my test will fail. For other reasons, we'd like the flexibility to run our tests in any order. But even if we didn't want that, having a cascade failures like this is a sure way to increase the complexity and so the unreliability and intermittency of our tests. So we want our tests to be atomic, isolated from one another, so that we can run them in any order alongside any other tests, or run the same test over and over again in the same version of the system under test and get the same results every single time. To solve this problem, we need to isolate our tests from one another. There are 3 levels of test isolation that I think are useful to think about. And my training course talks about each in a bit more detail. But you can use isolation at the level of the scope of the system that you are testing, to test to its boundaries and throw away that copy of the system at the end of the test. To upgrade your testing efficiency, it's usually best though to run tests in parallel in a shared copy of the system, so that you share out the costs of deploying and starting up the system under test. For this, we need to exert finer grained control. I recommend always using 2 ideas that I call functional and temporal isolation in acceptance tests. Use the natural functional boundaries in your system to isolate your tests from one another. Create new accounts or markets or products or games at the start of every test case. And use test infrastructure to generate unique names for these things. Now, the data that your test relies on in a specific run of this test is scoped on these defined ideas. And your copy of this test is the only place that can see this particular game or account, or whatever else it is that your system deals with. Effective test isolation means that there's no shared writable data between tests. Perhaps the commonest problems that teams have with intermittent results is down to poor version control. Having described this problem this way, I'm now imagining you thinking, does he mean version control systems? Well, yes and no. Version control systems are the answer. The problem is that many teams don't use them for this though. This version problem takes 2 common forms, and the answer to both is use version control systems. Looking at this from the perspective of what can break your tests, what happens if you change the version of the system under test but keeps the test the same? Will everything still work? You've no idea unless you try it. Similarly, changing the version of the test that you run against a specific version of the system under test can obviously cause problems, and you'll need to try that out too. Again, the simplest, most definitive answer is to keep your tests alongside the version of the code that they test in version control. So, if you keep the code for your system under test alongside the code for your tests, and all alongside the code that defines your host environments, life's suddenly all a lot simpler and a lot more predictable. The other way in which versions matter though is probably an even bigger deal. This is probably the most common failing that I see in teams struggling to adopt automated testing. Let's imagine that we have several teams working together on a system. Each is responsible for one part of the whole system. For simplicity, let's talk about 3 teams, but this is true whether we're talking about 3 or 300. The technical solutions for optimizing for 300 may be technically a bit more challenging, but the ideas are exactly the same. The problem here is, how do we answer the question, when's the overall system releasable? How can we tell? There are 2 strategies. We can work so that each team is wholly independent of the others. Their part of the system is sufficiently decoupled that they can release it whenever they like, without reference to other teams. This is great if you can work this way. This is the most scalable approach. This is called microservices. Yes, I know, I've said that kind of thing before, but look at the definition. Alternatively, if we can't be sure of that decoupling between those pieces, if we don't really trust it enough to release, then we have to try option 2. Now we'll have to test everything together before we release. This is no longer microservices, even if your services are small and have REST APIs. The bear trap that I see lots of teams fall into at this point is wanting to have their cake and eat it. They like what they've read about microservices and they're sure that monoliths are a bad idea, so they organise each team to work in isolation from all of the others because autonomy is good, right? And each team then churns out lots of new versions of their code very quickly because these are small isolated services. But how do they know which versions of the pieces work together? Because these services aren't really isolated, even if they are small. What most do at this point is to adopt some kind of integration test. This is the right idea actually, but usually they adopt it in the wrong way and run it much too infrequently. I've seen teams that spend literally weeks and months trying to assemble a working version of the whole system from these now incompatible pieces. The answer to this problem is continuous integration. We want an answer to the question which versions work together after essentially every commit, or at a minimum at least once per day. This allows teams to stay on top of changes in parts of the system that they're otherwise not really watching very closely. What this means is that the best way to define what releasable means for our work is to evaluate it at the scope of an independently deployable unit of software. If you have microservices, great, each is independently deployable. By definition, you can version control, build, test and release it as a single thing. If you have a collection of services, components or subsystems that together comprise a bigger system, that's fine too. But now your scope of version control, build, test and release is the whole lot. Now you've solved the version problem. You know which versions work together because they're all in version control together. You can do this with multiple repositories if you must. But now your dependency management is more complex and your interactions are slower, and what you must still have somewhere under version control for this to work is some kind of manifest that specifies exactly which versions of everything work together, and you know that because you tested them together. This is a problem that version control systems will solve for you, so why not just use that? I include resource use in my list of 5 things that can break tests for completeness too. To be honest though, compared to the others, this one's not really as big a problem. But the stability of our tests can certainly be compromised if some resource is overused in our tester environments. If you adopt the approach that I recommend, the profile of your system when being tested will probably be different to its profile when in production. We'll be faking data using techniques like functional and temporal isolation and in general working with it in a different way. So it's perfectly possible that you may hit resource limits in testing that you won't see in production. The reverse is also true, of course, and this is the job of production monitoring and targeted acceptance tests if you think it part of what defines the releasability of your system. The good news though is that the answer to resource constraints is actually pretty simple. If you've followed my advice here so far and everything is version controlled and automated, now adding more capacity to your test environment is really pretty simple. So that will address any intermittency that is caused by resource constraints in your test environment. The last cause of failure is the behaviour of the system itself. If we want our tests to be deterministic in terms of results, this is best if our system under test is deterministic too. Digital computers are deterministic devices. The degree to which they are not is really only down to 2 things. Where we consciously inject some form of randomness by design and then concurrency. There are various strategies to deal with each of these. Some of them about how we test things, like using time travel tests to take control of time in the scope of our testing, and some are architectural, like isolating concurrency in ways that mean that it is carefully managed in discrete parts of the system. Then the main work of the system, the part focused on solving real-world problems, can be more deterministic and so more testable. This is one of the reasons that I like event-based actor-style asynchronous reactive systems quite so much. These are very deterministic systems. The other impact that concurrency has on the stability of our testing is in handling race conditions. Again, we go into this in more detail in my training course, but fundamentally the idea here is to eliminate race conditions in our tests by waiting for a result for each invocation before moving on to the next instruction in the test. So if my test places an order for a book, my test infrastructure doesn't return control to the test case to do anything with that book until the order has been confirmed and we know that the book's available for any other interactions. So now my test can be simpler and more reliable. If you do all of these things, you have eliminated all of the causes of intermittency. Now, if your test is still intermittent, there's only one possible cause. Your test is now highlighting a real problem with intermittency in your system under test. And that's the result that you were looking for in the first place. Thank you very much for watching. If you enjoy my stuff, please consider supporting our work on this channel by joining our Patreon community. There's links in the description below, or go to Patreon and search for Continuous Delivery. Thanks again.